How are you doing, man? It's been a long time. It's been a while.
Yeah, it's been a while. Yeah, I'm continuing to improve. It's this I the long COVID really did a number on me. So I'm still recovering. It's been years, but I'm still recovering. But a couple of doctors contacted me um, from Australia
Okay.
and said that they thought from my symptoms, they heard me on a podcast, and they said they thought from my symptoms that the heart wasn't the primary thing that had been attacked, but it was my gut, that the virus is a bacteriophage, and that it destroyed the bacteria that produce GABA and serotonin and other calming kinds of things,
Yes.
and promoted bacteria that produce amines that sort of overdrive the heart and lead to the failure that I had.
Oh, gee.
And so they put me on this really strict diet, vegetables and no, basically almost no. It's almost like a total no carb kind of diet
See,
because
how's that been? Have you seen an impact?
well, yeah, it's completely changed my gut, and I actually it's making a huge difference. So this is, I mean, the virus attacks you wherever I guess you're weak, and it got me in the gut and the heart.
Jeez, man, I'm glad you're doing better though. It's always great to know someone's doing better, and I mean, we need you out there to continue doing such great work.
Well, thank you, and we need you to continue to do this great podcast, and of course the medical work that you do.
Thanks so much, Don. I mean, we've covered so much. We've chatted twice already, and both times we went through various different aspects of all your work. In the first podcast, we spoke about user interface theory of perception. We spoke about conscious realism. We touched on conscious agents, but in the second one, we went very in depth. Conscious agents in the subatomic world. We went into that paper. We dissected it. People loved it, by the way.
Good.
Yeah, no, it's been quite a hit. For this podcast, I thought let me curate a bunch of questions from the audience so far from the first two, and we'll try and go through each of them. But before we do that, I think since conscious agents in the subatomic world, what's happened since? Because I'm assuming you guys are having a lot of fun, and it's always exciting to when someone jumps and gets outside the box to know what's really outside the box.
That's right. So we have made a couple, for me, very fun discoveries. So one has to do with the notion of observation. What does it mean to observe? What will it mean in our theory for one system to observe another? In classical physics, the observer is not much mentioned, and if they're mentioned at all, they're assumed to be objective and don't really interfere at all with whatever it is that they're. So they don't disturb whatever they're observing. In quantum mechanics, there isn't a theory of the observer, but it's known that somehow the measurement process is a destructive process. I mean, things are different when you measure than when you don't, and so there's this feeling that the observer has to play a role, but it's not formalized, right? Their measurement is formalized. It's some kind of, there is a formalization there in terms of positive operator value measures and so POVMs and so forth. But even someone like Chris Fuchs, who's saying that quantum mechanics is really just a description for the agent, how it should update their beliefs in light of experimental data and so forth. But when you ask him, so what is your theory of the agent? He says, I don't owe you a theory of the agent. I'm just telling you that quantum mechanics is the manual that the agent should use, and I don't know what an agent is. And I respect, I mean, you can't do everything, and he's doing quantum mechanics, and he's not doing the agent. He's not doing the observer. But he does say that the agent's important. So then in our theory, then, the question comes front and center, because we're talking about conscious agents all the way down. So we can't avoid. So when we talk about a measurement, we have to actually have a theory of what does it mean for one system of conscious agents to make a measurement on another system of conscious agents, right? What does that mean? And we use, so I have to be a little technical to explain the idea. I'll try to be as untechnical as possible. But we use Markovian kernels. So a Markovian kernel basically says, suppose you have a system that can see three colors, red, green, and blue. And that's what it experiences. there's a kernel that we call the qualia kernel that describes the sequence of color experiences that this observer might have. So maybe if I see red now, the probability is that the next time I see a color, it'll be green, but maybe it's half. And it's also a third that I'll see blue, but it's also, whatever is left over, probability that I'll see red. So I can say for each color I'm now experiencing, what is the probability of the next color I might experience? And so when you write down a matrix, a table of all those probabilities, in mathematics, we call that a Markov kernel, and it's actually a linear operator. And you can actually study the properties of that linear operator. It can rotate vectors, it can expand and contract vectors, it can do all sorts of things. So that's one of the models we're using to represent observers and the conscious experiences that they have. Mm. What we discovered was, and this is a new contribution to Markov chain theory, apparently, to the mathematics of it, is that, well, first, what I'm about to say is not a new contribution. It's a standard notion, but we're going to use it for the new contribution. If you take one Markov chain, like it has 3 colors, and you've got the Markov chain on it, but then you say, what if I, don't look at the red. I don't care when the red. I'm only going to look at the green and blue, and I'm going to look at those 2 colors. What Markov chain gets induced on those 2 colors from the bigger Markov chain on red, green, and blue, right? There's some probability of going from red, green, blue. But what happens if I only can see the green and the blue? I'll get some chance, if I see green now, that I'll see blue next. If I see green now, I'll see green next. So I can actually, you can intuitively, say, well, yeah, you should be able to induce a Markov chain on the smaller number of states, right? But it would somehow respect the bigger Markov chain, right? So that's the idea of a trace. It's called a trace chain. Well, what we proved, this is work with Chetan Prakash. So he and I worked on this together, and what we found is that the relationship of being a trace chain to another Markov chain is a partial order. That means that we found this is an entire logic on the space of all Markov chains, all Markov kernels. So this is a brand new logic. One chain entails another if it's a trace chain of the other. The actual definition is simple. Once I can actually say so one Markov chain P is less than or equal to Markov chain Q if and only if P is a trace chain of Q. And you can prove that is actually a partial order, and it's a logic. So it's actually a logic on the space of all Markov chains. It's not Boolean. It's more general than Boolean. It's more general than quantum logics, ortho-complemented lattices. It's more general than that. It's locally Boolean. So every particular Markov kernel, if you look at all the ones that are less than it, all the ones that are less than it, they form a Boolean logic. So this is a locally Boolean logic of observation. And then we proved that this, if you take, so by the way, then this is our notion of observation. If one observer's kernel or Markov chain is less than or equal to another, then it observes the bigger chain. So notice our notion of observation is not this objective, you're outside the system. No, you're immersed in it. You are part of the system. You're an integral part of the system that you're observing. So at the top level, that's the take home from this. Our theory of observation is the observer is no scientist that's separate from everything and not involved in anything and completely separate and can be ignored. No, you are intimately part of the system, and you must be understood. To get a real theory of observation in science, you have to understand what an agent is and how it's embedded in the systems that it's observing. And this gives a mathematical logic for doing that. So it's really, we're pretty excited. But then each Markov chain, if you have Markov chains that are like recurrent communicating class, so they're in some sense they're nice Markov chains. I'll just use the word nice as a non-technical term, but I gave you the technical for those who want the technical recurrent communicating class. They have then a probability measure that tells you long-term what are the probabilities of the different states that you'll see. Like, what was the probability of seeing red? Maybe long-term you see red a third of the time, blue 2/3 of the time, and green you don't see hardly at all. Maybe that's the long-term that's called the stationary measure of the Markov chain. And so it turns out that when you have a big measure and then a big chain and a trace chain, that the stationary measure of the trace chain is exactly the restriction of the stationary measure of the bigger chain to that subset of states. In other words, it's all compatible. So you have a big measure for the stationary measure of the big guy, and maybe 3 of the states are what you trace on. Well, if you look at the big guy's probability measure on those 3 states, that's exactly what you get on the little guy, just renormalized so that it's a probability measure. You have to renormalize it so it's probability. So all of these stationary measures they follow through this logic. And it turns out this then means that there's this logic that we discovered on probability measures that I published 30 years ago. And I published it with Bruce Bennett, he's now dead, but a brilliant mathematician, and Parish Murthy, who was a graduate student of mathematics. So it's 2 mathematicians and a flunky, me, working on this thing. And we published it in the Journal of Math Psych, and what we proved is that there is a logic on probability measures where one probability measure implies another or entails another probability measure, if and only if it's a normalized restriction. So I get the bigger probability measure, I take a subset of its states, renormalize the probability on that, and that's the probability of this guy down here. Okay. It turns out so it's a simple idea. I'm just a normalized restriction of the bigger measure, but then that's the implication relation. And that gives you a non-Boolean logic. There's no global complement, just like by the way, this trace logic, there's no global complement. Okay. Locally there is, because you have a local Boolean logic, but globally not. So it turns out, now this last thing I'm about to say, we haven't proven yet, but we're going to try to do that. There's a homomorphism of the logics, that the trace logic is essentially homomorphic to what we call the Lebesgue logic of probability measures. So this gives us, the trace logic gives us a formal theory of observation, and the Lebesgue logic of probability measures gives us a formal theory of probabilistic belief. And so putting them together with this homomorphism shows how observations are formally related to probabilistic beliefs. Okay. So this is, for us, a major breakthrough in terms of the formalism. And we had to go after this because, you mentioned our paper on the subatomic world, so conscious agents in the subatomic world. Well, we have to say what we mean when we're talking about modeling observations of quarks and gluons inside the proton. What do we mean? Well, so now we have this. We mean that we're going to be positing some bigger Markov chain, and our observations will be some trace chains, right, of that bigger chain. And the trace chain will have two ways that it's doing this observation. One is the number of states that it's tracing on, right? So that's going to be one parameter. The more states you trace on, in some sense, the better spatial resolution you've got, right? Right. So if I have, if my big chain has 1,000 states, that would be a very big chain, or at least for my computer. And suppose I have a trace chain that's only 10 states versus another one that's 100 states versus another one that's 500 substates of the big chain, right? The one that 500 substates is in some sense a higher resolution observation than the one that only has 50 states. The 50 state one is observing the big one, the big 1,000 state one. It is observing it, but not nearly with the resolution of the 500 state one.
Almost like quantifying that sort of objective.
It gives you complete quantification, and for the physicists, this would be our quantification of what they call Q squared, which is their technical thing for spatial resolution. It's tied to the amount of energy that they use. So the higher energy leads to better spatial resolution. So what we're basically now doing is identifying higher energies with greater spatial resolution in our trace chains, which is that itself is a non-trivial statement.
There's a lot that's said there, obviously, because it's very complex, and a lot of people find it very difficult. I've noticed a lot of people find your theory so fascinating and want to jump on board so badly, but the math and the physics become so complicated that they just can't do it. And the only way I can is by first, obviously, chatting to you, watching, reading your content, but then chatting to friends who are physicists, trying to get their opinion on all of this, and trying from their perspective to understand what you're talking about. And the more I do this, the easier it gets to sort of understand it. But I still feel left in the dark, knowing that you have access to more information based on the base of knowledge you have within physics and mathematics. Have you felt that it's a bit of a struggle to try and get this out there because of the complexity of this topic? Do you feel people find that you're hiding behind these sort of fancy words? Because I've noticed a lot of people comment about that, saying that, okay, once you mention decorated permutations or once you mention Markov blankets, you're just trying to sound smart. But that's not the case, because when I chat to my physicist friends, they seem to know what you're talking about a lot better than the layman.
Right. And then, if someone thinks that, I mean, we have a paper called Fusions of Consciousness. So you can just go look at the paper Fusions of Consciousness, and you know, we don't just mention the word decorated permutation. We actually create a new mathematics of decorated permutations for Markov chains. So it's not just hand waves. I only talk about it because we're using it, and we're using it to good purpose.
I'll put a link to Fusions of Consciousness. No, I think that one came out in January, if I'm not mistaken.
In January. That's right. That's right. So I'll just mention that. So I agree with what you're saying, that it's difficult, and I try to talk about this stuff in a way that's generally accessible. But the problem is, of course, if you do that, then people say, well, it's not serious. And if you do it seriously, then I can't understand it. He's just throwing out these technical words. So it's a catch-22. But my attitude is, well, you know, I do get potential graduate students, and this is one reason why I do these podcasts. And young people, I'm interested in getting young people who are young enough that they can start to learn the math and make contributions, get them excited and get them, you know, studying this stuff. So I spent an hour and a half with one potential student yesterday, talking about, and gave her a bunch of math to read. And so you know, so that's what I'm doing it for, is to actually get graduate students working on their PhDs in this field. That's my goal. That's why I do the podcast.
I've noticed someone else who has this problem, because when I chatted, it's Carl Friston. When I chatted to Carl and we spoke about his approach to the free energy principle, he has exactly the same issue. He's often accused of hiding behind fancy talk, they sort of say. So it's, you really are stuck between a rock and a hard place. You can't. How do you dumb down something that is so complex? Do you find that there's a specific way you think that's best to approach this so far? Have you hacked the code yet?
Well, for communicating it, probably the best approach that I've seen so far to get people to take this idea seriously and to not just dismiss it is to point out the failure of physicalist theories.
Yes.
Right. That seems to I mean, because I'm someone might say, look, you know, the brain does it. I mean, forget all this stuff about conscious agents and so forth. I mean, look at all the physicalist theory. It's clear we have all these neural correlates of consciousness. We're almost there. We're getting these we got lots of neural correlates of consciousness. We have all these nice, you know, we have integrated information theory. We have orchestrated collapse of quantum states of microtubules. We have, you know, attention schema theory. There's IIT, I think I already mentioned integrated information. So there's just a bunch of these. Oh, global workspace theory is another big one, right? So global workspace theory. So you know, why do we need someone who's clearly off in woo-woo land, saying consciousness is fundamental and so forth? And so for me, the thing that I think is the most grabbing thing to say is, if you ask any of these theorists, you know, proponents of these theories, okay, you're integrated information theory. This is the theory about conscious experiences. Okay, so you're starting with some substrate, maybe it's physical or some other substrate, and you have this causal architecture that's got the right pattern of integrated information, and you're saying that that will explain the qualia of specific conscious experiences, the color green, the taste of chocolate, the smell of garlic, the experience of auditory space versus the experience of visual space, or the experience of haptic space as conscious experiences. So clearly you've been at this for a couple decades, so you must have a whole bunch of conscious experiences that you can now say, this is the pattern of integrated information that must be the taste of chocolate. So give me, what have you got? Zero.
Yeah.
And you go to every theory and you ask them, so what have you got? How many qualia have you given me the global workspace architecture for, or the orchestrated collapse of quantum states with neuronal microtubules, or integrated information, Q, what they call the Q shape? How many do you have? Zero in every case. So we have these theories that have been out there for decades now, that are batting zero. And I'm saying they're batting zero for principled reasons. Space-time, the physicists, the high energy theoretical physicists are telling us, space-time is not fundamental and reductionism is false. These theories are failing because they're not listening to modern high energy theoretical physicists that are telling us that game is over. We're playing an old game. It's like someone after Einstein trying to play the Newtonian game in understanding chemistry.
Yes.
Good luck. You can't understand chemistry using Newton. You have to use quantum mechanics. I'm sorry, I shouldn't have said Einstein. I should have said quantum theory.
Yes.
So,
Don, before you move on from that, because one of the questions from the audience. So I gathered a bunch from YouTube, Twitter, etc. Unfortunately, sometimes I forgot to actually write down the person's name, so I've just left them all out together. So I'm just going to ask you them at random. But one of the questions was directed at one of your statements, because you've said this before. You talk about the taste of chocolate. You talk about the smell of garlic. This person says that whenever you mention those specific states, they want to know, why do you want such a direct portion of consciousness? So let's say when you're asking for that qualitative qualia experience of the taste of chocolate, why go after a specific state? Because everything in the mind is so blurry, so mismatched. There's so much going on. There's so much, let's say, heuristics involved. Wouldn't that be a bad approach to trying to provide proof of a theory?
Well, all I'm doing is saying to the people who are offering these theories, like the integrated information theory or global workspace, whatever, they're the ones that are saying, we will start with neural activity or this Q shape or whatever, and we will give you conscious experiences. Like that, we will give you these experiences. I'm saying, okay, that's what you're promising to do. So I'm just asking you, since that's what you said you're going to do, I'm just asking you, how's it going? And by the way, I asked Giulio Tononi this back in late 1990s. He came to UC Irvine to our Helmholtz Club meeting, and I asked him that, and he didn't have any then. And then I asked him a few years ago in Canada at a conference. Asked him again, and he admitted he needed to offer one, and he couldn't. And I've same with Stuart Hammerhof. I mean, I had him at a conference in front of 400 or 500 people. I asked him, so Stuart, how's it going? I mean, you're promising that we'll start with these orchestrated collapses, and you'll give us specific conscious experiences. So which ones? I mean, that's what you claim that you're doing. So how many conscious experiences have you nailed down? And I had to push him for 3 or 4 minutes before he finally said, because he was hemming and hawing. And I said, no, Stuart, give me one. No, Stuart, give me one. And he finally said, no, I can't give you one. So I'm just, now if they want to say, we have these wonderful theories, integrated information theory, and they have nothing to do with the taste of chocolate and the smell of garlic, fine, then I won't ask you the question. But if they do say that, then hey, the science is science. Where's the beef? So that's why I do it.
Don, I'm curious about your opinion. It was about 2 months ago, I think, about the IIT soiree. I mean, it was such a major issue within the philosophy community and science community in general. What were your thoughts on that? Just for the context for the listeners, it's the whole debacle where IIT was accused of being pseudoscience.
Right. That's right. And when I looked at the letter that was put out there and the references that they gave, one of the things they referenced was Michael Graziano in a paper of his on attentional schema theory, where it basically says theory of consciousness is either mechanical or it's magical. And so the signers of that were basically signing on to, look, a theory of consciousness is either mechanical, and presumably neuromechanical, but maybe AI kind of mechanical, but most of them are thinking neuromechanical, right? Or it's magical. And so so the argument is that IIT is claiming some kind of substrate independence. There is a substrate, so that it doesn't say that consciousness is fundamental. It says there is a substrate to consciousness, but the substrate might not be physical. Of course, they're thinking it's physical, right? That's. Yeah. I mean, if I ask them, so how many non-physical substrates are have you concentrated? So what are you going to say? Ectoplasm? I don't know what. But anyway, they're saying that there's a substrate, but they're not committed to a neural. Put it this way: it's not necessarily a neural substrate. It could be some kind of computational architecture that's completely non-neural. So I don't think they're going non-physical, but they could be going non-neural. Mm. And so that means that they're dealing with something that it looks like a disembodied mathematical causal structure, right? Although the IIT people would of course say it has to be instantiated in something, so the substrate is important. But somehow they think that because they're not starting with neurons. Mm. They're not starting with neural circuitry or something like that and trying to show that leads to consciousness. They're starting with something more abstract and not necessarily mechanical. It's not like this fires and that fires and we have this circuit and so forth. It's more abstract mathematical kind of thing. So I'm just trying to explain the kind of get in the heads of the people they're worried about this. So they're concerned about that. Now, my attitude is I think that all of these theories have the problem that I just mentioned, which is there's no beef. There's no success in terms of specific conscious experiences. And what's happened is all the physicalists, I think that they're starting to understand that they have nothing in terms of concrete conscious experiences that they can explain. Mm. Without handwave. They're zero. They're forming a circular firing squad, right? They're shooting at each other, and everybody's vulnerable to the objection that I just gave. Yeah. The objection is you claim that you'll start with integrated information, or I start with higher order theory. Now we're doing neural stuff. Higher order theories or first order theories or global workspace theory. And I'm going to give you specific conscious experiences. Which one? Well, I can't give you any right now. Mm. How long have we been doing this? Decades. We've been doing this for decades. You can't give me one. So at some point, people get impatient and go, now I should say, I'm good friends. These are my friends and colleagues, right? So they're brilliant. Some of them are geniuses. All of them are brilliant, and some of them are geniuses. Why are they not making progress? It's not because they're not smart. They're brilliant. They're not making progress because we're not listening to what the high energy theoretical physicists are telling us. Space-time is doomed and reductionism is false. We have to listen to our best current science. It was fine 30 years ago to assume that space-time is fundamental and reductionism is the way to go. In fact, it was the right approach given our current science at the time. But it's no longer feasible. It's ignoring. It's frankly just ignoring our best science, and that's not what we want to do. So my prediction is as soon as these brilliant colleagues and friends of mine really understand that we need a new framework and they switch, I think all of a sudden we'll make some serious progress on this field. And we'll look back and realize that we're in sort of the flat earth period of this field. And as long as you assume flat Earth, you can't do a space program. As soon as you let go of flat Earth, then you start to have the tools that you need to actually start doing a space program.
So you mentioned Michael Graziano. He was actually he was the first person I interviewed on this podcast, and it feels like ages ago. But I remember him saying that if you take attention schema theory and you plop it on top of global workspace theory, he believes that together it actually would provide a very complete theory of consciousness. But I can't help but think, based on the fact that he's saying that, based on the fact that they used it's either mechanical or magical, do you think it would be similar to compare Michael's theory and global workspace if they continue to do as well as they do separately and maybe even together, to be the Newton's theory in physics or Newtonian physics of the brain? And then while you guys are going on to sort of do the Einstein's theory of consciousness, do you think you guys are going to approach consciousness in that sort of way?
Well, yeah. Now, I should be very, very clear that I think that the work that they're doing on getting models of the neural correlates of consciousness is brilliant and useful, and that will survive, right? But it's not a theory of the generation of consciousness. It's a theory about how we see consciousness correlated with parts of brain activity. But so I'm all for that. Now, my understanding about Graziano is, at least in some of his writings, I've gotten the impression that he thinks that conscious experience is in some sense an illusion. We have it's not there aren't really qualia, but we have the illusion.
It's a caricature. He calls it a caricature. He actually intentionally avoids the word illusion.
Right. So if he doesn't want to use the word illusion, Keith Frankish does. So yeah. Keith does use the word illusion, and if Michael wants to use caricature, that's fine. But as a scientist, my feeling, I'll say first about the illusion approach. And I've said this Keith is a great guy. I really enjoy talking with him. I feel he's a friend and so forth. But I've pointed this out to him, and he hasn't demurred. That saying that it's an illusion doesn't get him off the hook, because we now need a scientific theory about what specific pattern of brain activity must be the illusion of the taste of chocolate and could not be the illusion of garlic. So you might think, oh, well, now that they said it's an illusion, they don't have the problem that Hoffman's bringing up. No. Yeah. They have, we have to do science here. If you're saying it's an illusion, I want to have a precise scientific theory about why that has to be that illusion and couldn't be, this other illusion.
They call it the illusion problem.
That's right. And I would say the same thing, from Graziano. If it's a caricature, then why should this particular brain activity be the caricature of the color green and not the caricature of the color red? I want to, again, as a scientist, I don't want to hand wave, and I don't want to say because I called it a caricature, I don't owe you a scientific theory. I'm not interested. I'm interested in results. I want a theory, whether it says it's an illusion or a caricature or the real qualia. I want a theory that gives me the beef and says this pattern must be this caricature and it couldn't be that caricature. Otherwise, philosophy is fine. I have a joint appointment in philosophy. I love philosophy, but I'm talking science here. And so I want a scientific theory. So that's sort of my attitude about that whole thing.
Yeah. And I think, but what I was trying to get at was, it will still be very useful, and it will actually work in the sense that in the same way Newtonian physics works, because we still use it. It's still very practical. It just doesn't go away. So in that sense, it will still be very, very good at its job.
I agree. But also you'll have some, with Newton, you have some misconceptions. You have the idea that, well, I should be able to get the position and the momentum at the same time to arbitrary accuracy when I'm looking at stuff. Right. And so you're led to believe certain things. Well, that turned out to be false. Yeah. And so absolutely, Newton is great. If you want to send a rocket to the moon, it'll work. And for a lot of everyday stuff. But sometimes it leads you into conceptual errors, like the position momentum. And something like these physicalist theories, I think they will be very, very good for the neural correlates of consciousness and so forth. But they're going to lead to some they are leading to what I think are fundamental errors. And I'll name one that I think is a crucial error. They want to make a distinction between which circuits of the brain or which physical objects in general are conscious, which ones are not. So they want to use IIT in hospitals to determine whether someone's a vegetable or not. Should we pull the plug or not? So that's something that you as a doctor are quite interested in, I'm sure.
Yes.
And so they're making the assumption that some physical systems are associated with consciousness and others are not. That's their assumption. Okay. Now, if it turns out that space-time isn't fundamental and objects in space-time are not fundamental, in other words, if we listen to what the high-energy theoretical physicists are telling us, and they're saying that there are structures outside of space-time, and they're finding them like amplitude-hedron and decorated permutations. What is space-time? It's not the fundamental reality anymore, and objects in space-time are not. So now we have to understand what is that. And so what I'm proposing is that space-time and objects in space-time are just a headset, just an interface. So think about it that way. So here I'm using an interface to talk with you, and I see I'm using Zoom. We're talking via Zoom, and I see a bunch of pixels on the screen, and I see pixels of Tevin's face, and I see also pixels of a wall behind you. Now, I'm getting a lot of conscious input from the pixels on your face. I mean, I can see your expression. I can see if you're interested or not. The pixels on the wall, not much. Now, I could say, aha, so I want to have the pixel correlates of consciousness. Aha, so these are the conscious pixels. The ones on, and those are the conscious pixels in Tevin's space, and the ones on the wall, those are not conscious pixels. And so now I'm going to have, my little mathematical model and say, these pixels are conscious and those pixels are not, because these have some complicated pattern of interaction and those do not. Well, that's completely wrong-headed. Pixels are pixels, period. Some and they're not conscious or unconscious. They're merely a headset, an interface. Some pixels give me access to a consciousness behind the Zoom, and others don't. And so when you realize that, that is a fundamental difference here, right? If we use something like integrated information theory, which is saying certain physical systems are conscious and others are not, I'm saying that claim is absolutely false. And it's dangerous to assume it in hospital settings. So this is no longer academic.
Yeah, so now this goes beyond. This is very practical. This becomes very important for us as a society. And that's actually the main, when I started the podcast, one of the description layers was this podcast's function is to show just how difficult intellectually and practically the mind-body problem is. Because the moment you do finally figure out whatever theory of consciousness you want to develop and grow, it has so many practical implications. And in this case, I mean, you're touching on a very, very big one. I mean, death. We're talking life and death at this point.
Absolutely. And pulling the plug or not. And it's if the foundation is so wrong that it's actually, it's at the level of saying these pixels are conscious and these pixels are not, is that kind of error, then we have to be very, very careful about it. So this is not just academic anymore. Saying that space-time is a headset has real implications, moral implications, and technological implications. And it also has implications for the whole debate about can AIs be conscious, right? This gives you the standard way that that's considered. And again, it brings up all sorts of moral questions that people are worried about. But the way it's thought about is we have a physical system that a priori is not conscious. Somehow, if we give it the right kind of complexity, computational complexity, it will be conscious. Well, that's exactly the same mistake as saying if I get the right kind of complexity in the Zoom pixel activity, it'll be consciousness. No, it's not. It's just, so certain Zoom pixels give me a portal into Tevin's consciousness, and other Zoom pixels on my screen don't give me any portals into Tevin's consciousness. The pixels are not conscious or unconscious. It's about the headset and how it's engaged to what's beyond space-time, what's outside the space-time, and how it's effectively or not effectively giving us access to what's beyond space-time. The whole point of a headset is to simplify things. And at some point, you're going to simplify things so much that you can't really say much about it, right?
Mm.
When I look at you, my interface has given me a portal into your consciousness that's good, not perfect. Even if you've lived with someone, you've been married to someone for 30 years, you find out that there's things you don't know, right? So it's not a perfect portal. But when I look at my cat, the portal is even worse. And when I look at an ant, it's even worse. And a microbe, it's even worse. When I look at a rock, my headset has given up, because headsets are there to simplify things. At some point, it has to give up.
Mm.
So it's not that the rock is, it's not that like the Tevan human body is conscious or not conscious, and the rock is conscious or not conscious. It's just that these are symbols that give us portals into a pre-existing consciousness or not. In the case of the rock, my idea is that we're interacting with consciousness all the time, but when I see a rock, I'm not getting much insight into the consciousness that I'm interacting with. It's not, so I'm not saying the rock is conscious. It's not panpsychism. So I'm not a panpsychist. Headset is a headset. Consciousness is consciousness. Now, I'm not saying that, see, most panpsychists are thinking that space-time is fundamental, particles are fundamental, but behind the equations of physics and behind the particles, what breathes fire into the equations and life into the particles is consciousness inside space-time. But we'll keep the same laws of physics and so forth, so consciousness is sort of almost along for the ride. But the laws of physics are really doing all the. I'm good friends with Philip Goff, and we have good discussions on that. And Philip has said to me that he's willing to let go of space-time, but we'll see. I'll push to let go of that. And if he does, I think we'll be very, very close in our views. But so I think that. Well, I think I'll just stop there.
I'm going to chat to Philip, and I think Jan or Feb, I can't remember when we scheduled it, but I'm going to ask him about this. I'm going to see how close he's gotten to that sort of conversion. But I'm glad you're touching, so as it stands, Don, you're touching on some practical stuff at the moment. And this is what I sort of premised a lot of these questions on, which is great, because I think that these practical implications of understanding this headset or understanding this virtual reality, this matrix, whatever people want to call it, it's pretty much the same thing. You are saying that this world we're living in is a sort of simulation in that sense. It is a virtual reality. Some people love using the word matrix. Just to be clear, it's not the same type of matrix as from the movie.
Right.
But nevertheless, the word matrix seems to be now synonymous with simulation. In this virtual reality, let me just go to this question that I have for you. How do mental health or mental disabilities work within this sort of framework? Does your work now give you a sort of, I know you have to now almost become a philosopher and sort of maybe even guesstimate certain aspects of this, because it's very difficult to go outside this box already and to go even further beyond space-time to now give me mental health theories is going to be even more difficult. But just out of curiosity, what is it? Is it a bug in the actual virtual reality? What's going on here?
Well, so the way I think about it is that space and time, and what we see in space and time is just a headset. And behind the headset is this realm of conscious agents. So that's another part of the ontology that we're proposing. Uh-huh. I'm not saying I'm right. I'm just saying I'm trying to be precise, and I got to say something specific. So I'm saying that there's a vast social network of conscious agents that in some sense probably ultimately I'll realize that there's one conscious agent, and this network is just a nice analytic tool that I have to use as a scientist. So I'll talk about there's one conscious agent, but I'm using this network because that's what I need to use to do mathematics. So that one conscious agent, what is it up to? And why, right? I don't know. So I will guess, but one possibility is it's a theorem that no system can ever understand itself completely. Mm-hmm. If I have a computer system and it wants to understand itself, it has to build a model of itself. Well, as soon as it builds a model of itself, now it's more complicated. So now to understand itself, the new self with the model is going to have to model itself with a model. And you get in this infinite recursion. Mm. So so maybe the one infinite consciousness, which transcends any particular instantiation, like a space-time instantiation or whatever, we have a 3 dimensions of space, 1 dimension of time. What about a 50 dimensions of space and 1 dimension of time? I can see 7 million colors. Why not 20 trillion colors? And new, in other words, this is just one possible form instantiation that the consciousness can use out of an infinite potential to look at itself. So what consciousness is up to is looking at itself from different perspectives, and then losing itself in the perspective. Identify. So I'm now identified with the Hoffman body. I think I'm only, I'm just that, and I'm nothing more, and I'm afraid of death, and the whole bit. And then slowly waking up and realizing, oh no, I now know myself because I know I'm not Hoffman, and I'm not. So all the stuff that I thought I was, and I immersed myself, both feet. I jumped in with both feet on this thing, and spent 70 years, 80 years, 90 years, and then woke up. And now I know myself because I know I know myself better because I know I'm not that. So knowing yourself by a bunch of negations. And so now from that point of view, the one can know itself by being a paraplegic or having Alzheimer's, or you're having any kind of mental disease you want, some kind of nervous breakdown. I just have nervous breakdowns all the time, or whatever it might be. Or I also experience myself as being the world's fastest Olympic runner.
Yeah.
And the world's Einstein, and then I'll wake up but I'm not that either. So in other words, essentially, even behind someone who looks completely debilitated is this infinite consciousness just looking at itself. So in that point of view, everything deserves equal respect, right? So there's a moral aspect to this, which says, when I see someone who has an IQ of 50, there's no difference between me and that. When I look at my cat, I am the same one consciousness that's also looking at me through the cat. Those are just different avatars of the one consciousness from this point of view. So what happens from this point of view is there is no grounds for putting barriers between me and anybody else. This actually says I am that, just looking at it through a different interface. And this, I think, is the foundation for a genuine love. That love is recognizing, it's not just loving the other as yourself, it's recognizing that the other is yourself. It's you, the infinite consciousness, looking at yourself through a different avatar.
Yeah, it's you see this sort of play out in a lot of ancient cultures as well, where, let's say, someone goes out and hunts for food. They kill the animal and they sort of pray to it, hug it, do a sort of sing songs around it, because they know they have to eat this being that is sort of still part of them. Yeah. And this is quite a recurring theme with religions, with sort of spiritualists. And I've noticed a lot of idealist theories in general tend to lead to this.
That's right. I didn't intend to go there.
Yeah, which is quite fascinating.
I mean, I was just sort of led by, if I'm going to assume that consciousness is fundamental, and it's one step after another, and I sort of led kicking and screaming to this. But now that I've gone there, it starts to make sense. It's so counterintuitive, but that counterintuitiveness might just be the one jumped in with both feet, and it let itself get completely lost in it. In other words, if you're really going to know that you're not that, you have to believe that you are it for a while. You really let yourself believe it, and then wake up, and then you really you took that very, very seriously. You really understood what it meant to be a Tevin or a Don or a Michael Graziano or whoever it might be. You learned what it meant to be that, and then you realize, I'm not that. I am this consciousness that transcends that.
It's like when Bernardo talks about this dissociated alters, I mean, of a universal mind, Bernardo Kastrup, when he says it's pretty much the same thing, that universal mind, and we're just these avatars or dissociated alters of the same sort of entity. There is no separation here at all.
That's right. So I'm pretty much on the same page with Bernardo on most things. One little wrinkle that we add, though, and it may not be just a little wrinkle, is that this trace logic that I mentioned at the start is the first formal structure I found outside of spacetime about the structure of the one. And it's a non-Boolean logic, and there's no global complement. So this is the first hint I've gotten of a structure, and I'm not saying that this is the final word about the structure of the one. Absolutely not. But it's the first baby step, and the first baby step in terms of a mathematical model of quote unquote God,
yes.
of the one, is already blowing my mind, because it's not clear what the word one even means. If this thing is not a Boolean logic, there is no like one top Markovian kernel. So I use the word one, but right now when I use it, already my math is telling me, Don, you're gonna have to think deeper. That the word one doesn't that whatever kind of unity that is not a trivial unity, and it's not a Boolean logic by any means. So what do you mean by the one? So already the math. I might be using the same words that religious people have used for thousands of years.
Yes.
But already the math is telling me this goes way, way deeper than I'd ever imagined, and probably way deeper than the human mind, because of the interface limitations we have, could ever understand.
Look, because that's another one of my questions at some point. I mean, how far do you think you're going to get, Don, knowing that we are limited? In essence, and we never really evolved the capability to perceive truth. I mean, we know the difference between proofs and truths, of radicality. How close do you really think that this will take you?
Well,
I mean, that's
strengths and weaknesses.
So, sorry, I was going to say that's always a tough question. I mean, when we know that we're so limited, it's so difficult for us to really go beyond anything further and deeper. Does that ever keep you up at night?
Well, I think about it quite a bit. I try to do it during the day. But here's one important aspect of it, though, and that is, what is the nature of scientific theory building? What are scientific theories? What do we mean by scientific theory? A theory in science says, please grant me these assumptions. And if you grant me these assumptions and I can make them mathematically precise, so I'll make these assumptions mathematically precise, then I can derive and predict all these wonderful things. And so that's, and if you do it right, the mathematical description of the theory will tell you the scope of those assumptions, how much that they can really do, their power, and it'll also tell you the limits, like Einstein's special theory and general theory of relativity. They tell you it's great scope. The mathematics tells you it's incredible. It predicts black holes and all this other. It's amazing stuff. It works really well. It also tells you, when you combine it with Einstein's contribution to quantum theory, E equals h nu. When you combine that with that, it tells you that space-time is doomed at 10 to the minus 33 centimeters. So it tells you that Einstein's theory, his beautiful theory, it tells you the scope and the limits. 10 to the minus 33, that theory dies. 10 to the minus 43 seconds, it's over. So now you might say, well, of course, that's true of any theory, but I can now give you a deeper theory that explains those assumptions of the theory that you just, so I'll give you a deeper theory. Absolutely, you can always get a deeper theory, but your new deeper theory will have its own assumptions. And this goes on ad infinitum. So my take on it is, science is one of the best tools we have. And I'm doing science. I love science. And science, after billions and billions of years, if we continue to do it for billions and billions of years, the fraction of knowledge that we would have about reality is precisely measure zero. Right? Precisely measure zero. And yet, we have to do it. We can never with science write a theory of everything. So when we talk about a theory of everything, the real scientists do it with a wink and a nod.
Yes.
Right. It's a theory of everything so far.
Yeah.
And so far is pretty trivial. So I think it's in principle the case that scientific theories can never be a theory of everything, but they can tell us their limits. That's what's powerful about science. The theories of science tell us their limits. Like the theory of evolution by natural selection actually entails that space-time isn't fundamental. And Einstein's theory of space-time entails that space-time isn't fundamental. These theories tell you their limits, right? Because evolution by natural selection, the way Darwin was thinking about it, is talking about organisms in space and time, competing for resources in space and time. And when you look at evolutionary game theory, it tells you that the very categories of space and time and objects are not the fundamental reality. Those are just headset categories. So it tells you its limits. I think what our theories do that's essential is they do tell us truths about the particular perspective that our headset gives us. So science can give us truths about our headset. There's an infinite reality of consciousness that transcends any scientific theory. But we can look at different perspectives on that, different possible headsets. Right now, all of science has been looking at a particular space-time headset, 3 dimensions of space, 1 dimension of time, 10 to the minus 33 centimeters. It's over with. It's a fairly cheap headset. We thought it was the final reality. It just turned out to be a knockoff cheap headset. But now we've learned the tools inside the headset. We studied the headset. We thought we were studying the truth. It was just a headset. But now we have the tools. We can step outside the headset and imagine other headsets and imagine, and that's all my theory of conscious agents is. It's just a projecting model of consciousness. It's no longer taking space-time as fundamental, it's taking consciousness as fundamental, but I'm recognizing I can never get a theory of the ultimate consciousness. Let me start off with little networks of conscious agents because I can model that. And that's just going to be a projection at best of the deeper reality. So that's what, so every question you ask, I mean, the answer is not trivial. Science can never get a theory of everything, but we can get good theories of projections of reality.
Yes.
And then just to put a spiritual twist on it, but you are that reality. You are from this point of view. And in some sense, you can know it firsthand by just letting go of any theory and letting go of it and just being. So when you just sit, in meditation, that is the closest you're going to get to what transcends any scientific theory.
It's incredible because I've chatted to you many times and I know how you think, and I can tell, well, I don't know exactly how you think, but I know how science-minded you are and how much it must perhaps annoy you when you're clumped into categories of thinkers when you are actively doing science. Because I know that there are many people I've spoken to on this channel who have the same problem. The moment you step outside any sort of status quo, you're automatically grouped together as either some sort of a hippie scientist or a spiritualist thinker. And they give you these labels that I think are unwarranted and for the most part unfair. And someone who has a similar issue is Thomas Campbell, because when I spoke to him, your theories are very similar. And one of the questions I wrote down here, and he really hates this because he's trying his best to not be associated with any form of religion, sort of dogma, because he does try and explain things outside of the realm of what we say, quote unquote, is normal. The question I have here is, and this is not from me, this is from one of the viewers, where does Thomas Campbell's theory start and Donald Hoffman's theory end? They're just trying to ask, what's the difference between these two different types of virtual realities you guys are talking about? Because they're both very similar, and yet they are very different. I think this person obviously just does not see the greater detail in them.
Right. So I did have a conversation with Tom, and so I could actually point out there is a podcast where Tom and I go into this in great detail. So I can
try and put a link to it. Yeah.
Yeah, I'll give you the link to it. So I'll just give a short answer because that's I mean, Tom and I go at it for an hour or two. So,
okay, right.
And it's very friendly, of course, very friendly. So he calls it my big toe, his theory, big theory of everything. And so I just given you my
you did
thought the theory of everything, what that means. And so I, at the very end of our conversation, I pushed him on it. I said, look, there is no such thing as a theory of everything. Wouldn't you agree? And he ultimately he agreed. There is no theory of everything. So initially I thought that might be a big difference between us, but I really wanted to find out. I mean, do you really believe, Tom, that you've got the final word on truth with your theory? Because I don't. If you do believe that, then my theory is utterly different from yours, because I think all I've got is a little tiny baby step outside of our headset, and that's all I've got. And I'm never going to have a theory of everything. So we now. The difference I see between us, just in terms of practical theory building, is he's using a lot of quantum theoretical ideas in his approach, right? A lot of it is using, I mean, he's got advanced, I guess he didn't get his PhD, but he's done advanced research and advanced study, graduate study in physics.
I think he does. I think he's in nuclear.
Does he have a PhD?
Yeah, in nuclear physics. Yeah.
Okay, so he does have a PhD in nuclear physics. Okay, good. So he's a genuine PhD in physics, and I think that he's trying to use quantum theory. His sort of quantum ideas are foundational in what he's trying to build. And from my point of view, again, the high energy theoretical physicists in the last 20 years are telling us that not only is space-time doomed, quantum theory is doomed. Yes. That they're saying that quantum theory will arise joined at the hip with space-time. And so you might say, well, there's all this weird stuff about quantum mechanics. There's the no cloning theorem. You can't clone quantum bits. There's superposition. There's entanglement. This is all weird stuff. And this is surely showing us something deeper about maybe a conscious reality and beyond space-time. And the answer appears that from the work of Chris Fuchs on quantum Bayesianism and Robert Speckens, his toy model of quantum physics, all of those weirdnesses of quantum theory, no cloning theorem, superposition, entanglement, all that stuff, is simply a symptom of incomplete information. If you have incomplete information about the state of a system, those all follow as theorems. Well, when I say that space-time is a headset, that means incomplete information. Your headset is there to chop down the information. That's the whole point of an interface, is it's too complicated out there, so let's dumb it down. Well, so quantum mechanics and all the weirdness of quantum mechanics is merely a symptom of the fact that space-time is doomed. So it's not going to give us, so quantum theory by itself is not going to take us outside space-time. Quantum theory has its weirdnesses because it's tied to the limits of space-time. So what's different between my approach and Tom's is, and most, by the way, most people who are trying to use some kind of modern physics to do some kind of exploration of consciousness, they're tied to, many of them are quantum is it, right? And I'm saying, not if you believe the high energy theoretical physicists, it's not it. Yeah. It's going to arise from deeper structures. And by the way, it's not a hand wave. So they found, like, the amplituhedron.
Yes.
Is a structure outside of space-time. It's a real structure. It's published. You can go read about it. Its volumes give you the scattering amplitudes of real processes in space-time, much easier than doing Feynman diagrams in space-time. Hundreds of pages of Feynman diagrams, turn into 2 or 3 terms you can do by hand. And there are no Hilbert spaces to be seen anywhere in the amplituhedron. And therefore, there is no quantum theory. And the physics, like Nima Arkani Hamed and these guys who are doing this, are very, very clear. There is no quantum theory here. This is beyond space-time and quantum theory. Unitarity, which is one of the key things. We can talk about unitarity. I mean, there are some who argue that unitarity is not essential to quantum theory, but most physicists would say it is. Unitarity and locality are are products of this thing, but they're not built into the thing. They can give it to you in the projection, but they are outside of space-time, and they're outside of quantum theory. Mm-hmm. So it's, you can see that the difference, maybe at some level, Tom and I, our concepts are similar, but the spirit in which we're doing things is very, very different. Yeah. I'm saying I'm letting go of quantum theory entirely. Mm-hmm. I'm letting go of space-time entirely. And I feel like that Tom is still saying, let me use the tools of quantum theory and the most advanced physics we have of space-time
mm-hmm.
to get my model of consciousness. I'm saying we really have to jump outside of the headset altogether.
Yes. No, I agree with you, because I found that question quite redundant in the sense that there are clear differences in the way you guys approach it. I think where you guys do start to sort of become similar is when it starts becoming a virtual reality, and when you start talking about that. But then I have another question from someone, and this question is directed at the both of us, actually. Okay. Of a critique for the two of us. It says, in our last conversation on conscious agents and the subatomic world, Tev, you and Don do not define information. And this should, so the person's basically, it's a very lengthy comment, goes on to say that we didn't clearly define the term information. And since the work eventually goes so much into a sort of a virtual reality, a sort of matrix simulation, information becomes a key word here. Should we clarify that for this listener, just to make sure they understand?
Right. I use Shannon information. So people who've studied information theory, if I have, it's all about probabilities, and it's basically, if something has probability p, then it's minus log p. Mm-hmm. So Shannon information. Now, when I use entropy, I'm using the standard, Shannon notion of entropy mm-hmm. from information theory. So this is, I'm just using standard standard information theoretic stuff. I've explored solace entropy. So there are generalizations of Shannon entropy and some arguments for that. So I've been exploring them, but I haven't used them yet. And if I'm forced to, I may. There are arguments for showing that the notion of entropy that's used in Shannon information theory may not be as general as we need in certain cases, and there are more. And one is called solace entropy, I think. And so I am playing with that. But when in my conversations with you, when I've said entropy or information, it's Shannon.
Okay, good. The next one is, if we're just avatars within this virtual reality, what is the concept of procreation? What purpose does this serve in the creation of other avatars? And does this even work inside of space-time?
Right. So what's interesting is that from this point of view, our headset gives us certain portals into the deep consciousness beyond. That's what the headset is for, too. So right now, my Tevin icon on my headset is giving me a portal into Tevin's consciousness, or that projection of the one consciousness, the Tevin projection of the one consciousness. So we know that our headset does give us portals into consciousness. And the question is, what technologies might there be that we could use to create new portals into consciousness, right? Well, we have one technology that we know, and that is having babies. That's one technology for opening up new portals into consciousness. So why would, so there are a couple of questions related to this. So why would the one consciousness use this procreation kind of approach toward doing this? And I would say that it's, first I should say I don't know, but I'll give you some ideas. Right, right. Humility is required at every step of this, right? I mean, until we have a scientific theory where we're making predictions, disclaimers everywhere. But at some point, I think we'll be able to reverse engineer the headset and understand this notion of portal that I'm talking about quite precisely. And we'll understand a little bit more how procreation works in terms of booting up new portals. And we'll be able to build artificial portals. We'll get to technology to build artificial portals to the consciousness behind. we'll actually understand what kind of networking of conscious agents is required to effectively bridge into our interface, into our common headset. So, but at the top level, why is the one doing this? It goes back to what we talked about before, which is the one is trying to know itself, and it can only know itself by knowing what it's not.
So to keep having more experiences and opening this up to a sort of multiplex of different experiences overall, which goes into the other question that I have here, which is, in this framework then, would dinosaurs and all sort of extinct species and creatures fall into this sort of process? Have these all been avatars as part of an experience of the one?
Of the one. Exactly. They would be. And you might say, well, why did the one do that and then throw them away? And what a waste of time. And that gets the whole notion of time itself is an artifact of our interface. So so a lot of our intuitions are tied to artifacts of our headset. So in our Markovian dynamics of conscious agents, the dynamics need not have increasing entropy. There need not be an arrow of time in the dynamics outside of our headset. But it's a theorem that if you take this Markovian dynamics in which the entropy is constant, it doesn't increase, and you make a projection by conditional probability. So you're losing some information. You see the dynamics, you see a dynamical system, but it's lost some information over the deeper dynamics. The projected dynamical system will have increasing entropy. And so it will have an arrow of time not as an insight into reality. It's not an insight. It's entirely an artifact of the loss of information. And so, and by the way, time is the fundamental limited resource in evolution. If I don't get food in time, I die. If I don't mate in time, I die. If I don't run away from that dinosaur in time, I'll be eaten. So time is the fundamental limited resource. And what I'm saying is that time is an illusion. It's an artifact of the headset. So the entire, so on the one hand, I've published papers on evolution and evolutionary game theory, where I love the theory of evolution. It's an incredibly powerful theory. Evolutionary game theory is beautiful. And inside the headset, there is no better theory of biological organisms than evolution by natural selection. It's brilliant. That being said, the theory itself, all of it, is an artifact of the projection. None of it is deeply true. It's only true in our headset. And for understanding dynamics in our headset, there is no better scientific tool than evolution by natural selection. And I've used it. But our mathematics tells us that the whole thing is an illusion. So I should maybe stop there. There is a question some people ask me, which is I use evolution to show that we don't see reality as it is, but then that means that evolution wasn't true. So how am I not shooting myself in the foot? Yeah. So if we have time at the end, we can go after why I'm not shooting myself in the foot.
Yeah. So Don, within this headset and having this headset on, can I take it off?
I think yes.
How? And
I think in the meditation process, when you literally, and most, myself included, are not great meditators, but
I try my best.
I hear about, I try a bit, but I do hear about people that I trust, that go to places where you let go of the headset for a while. You just literally let go. Death. The near-death experiences that people report, the Raymond Moody, I guess, and the tunnel, the light tunnel, and life review, and that common thing. I'm not saying that that's right, but it's suggestive that, and it certainly fits in with the ontology of this conscious agent dynamics that I'm working on. That in some sense, everything that I perceive is just a headset, and death is just taking the headset off. That's all it is. I tried that, but if you're playing a virtual reality game and you believe, and it's you've got an avatar in the game, so it's a first person perspective in if you identify with that avatar, if you really believe that that avatar is you, you're going to be nervous and scared, and everything that happens to the avatar is going to be. But if you don't identify with the avatar, you can enjoy the game. And if your avatar gets shot up, who cares? You just take the headset off. And so I think that it is possible, maybe in meditation, maybe not. Hoffman hasn't done it, so I'll just tell you up front, I've not gone there. I've meditated quite a bit, so maybe I'm just a spiritual flunky. Who knows?
Science flunky and spiritual flunky.
Science flunky and spiritual flunky. But the people that I trust seem to have had those experiences, and my own theory says it's possible, even though I myself haven't experienced it. So.
Let's say within this kernels of, or from the physics, from your mathematical side, let's say you leave the headset now. Would you have to first go via each pathway in order to get to sort of the one, or like would you see someone else between them? I'm not sure if you understand what I'm trying to say.
A really great question, and I've really wondered about that myself, because there are some spiritual traditions which talk about, I was some tutu warrior in my previous life or something like that, and so I've wondered if there's any way that I could make sense of that in my framework of conscious agents. Is there some kind of, like, if I take the network idea seriously, are there parts of the network that I could say that are sort of closer to this particular headset, the Hoffman headset? Maybe there are other headsets that are closer to that headset, and it may be possible that they're, and even though ultimately time is an illusion, it could be like we might be able to explain that illusion in terms of projections of these headsets and so forth. So I can't rule out the possibility that our theory will eventually take these non-precise ideas and make them mathematically precise and maybe even interesting. So I can't rule that out.
That's very fascinating. That can be quite a rabbit hole to go down through. Do you think that? Well, another thing that could lead to is sort of reincarnative experiences in general. I mean, let's say you sort of leave that headset and maybe just enter another one altogether. I mean, it opens up the door to sort of all those spiritual claims that, let's say, Hindus or Buddhists sort of have. It kind of provides a scientific grounding for these beliefs, in a sense.
That's right. It's basically what I was saying earlier is what you're saying is basically the one looks through the headset of an amoeba and of a virus and of a bacterium. And of Hoffman and Tevin and every possible headset, a cat, they're all legitimate ways of the one looking at itself and enjoying that view, and then recognizing I'm not that, I'm more than that.
And Don, how would you differentiate between something that's an avatar and something that isn't? So, like a virus, for example, we're not. A lot of doctors can't even. Well, people can't even agree whether it's living or dead. At what point is an avatar in this framework, would you say? What is the minimal amount needed to be an avatar?
That's a great question, because it really exposes an important concept here. And that is, in this framework, the distinction between living and non-living is not principled. Just as the distinction between conscious and not conscious is not a principled distinction. The distinction that we make between living and non-living is entirely an artifact of the limits of our interface.
Okay.
It's not principled. So I'm always interacting with living consciousness. I'm always interacting with it. And my headset is dumbing things down because I'm not, that's what I'm doing. I'm looking at myself through a projection. So when I see a rock, it's fair enough within my headset to say it's not alive. It's perfectly fine for everyday practical purpose. I'm not going to try to eat the rock and so forth. I'm not going to worry about the rock chasing me. And so for practical purposes, I can say it's not alive. But the distinction is not principled. I'm always when I interact with a rock, I'm interacting through a headset interface icon, namely the rock. I'm interacting with consciousness. I'm not saying the rock is conscious, so this is not panpsychism of that kind. The rock is not conscious. The rock like the zoom pixels, right? The zoom pixels are just zoom pixels. They're not conscious or unconscious. They're just zoom pixels. The rock is just a rock. What am I interacting with? A living consciousness, always. So now my interface can give me more or less information about someone else's interface with other humans.
Yes.
I know firsthand what a human interface is like. This interface, so I have some idea what it's like to be you, and you as a doctor, if you're dealing with patients with psychological problems, you have some insight. Whereas if you're dealing with a mouse, you might not trust your insights from the human experience in terms of understanding the psychology of a mouse, right? You just don't have the insights into their headset that you have into the human headset. Well, so when I see something that I call a virus, I have some hint in my interface of something that's like alive, but my interface is giving me almost no information about another interface.
Yes.
So interfaces have information about other interfaces that is more or less complete. And so with the rock, my knowledge of interfaces is basically gone to zero.
Okay, yeah. So that's just beyond that interface's right. access at that point.
Right. That's exactly right. That's right. That also by the way, things that look really stupid to us, like I see some worm crawling around and it looks like really, really stupid. Hey, for all I know, what I'm interacting with there, if I could get inside and understand what it was experiencing, what I might just want to fall down on my knees and worship it because it's so much smarter than me and brilliant than me.
Yeah.
Again, what I can see about others is just due to the limitations of my own headset, and what they are in themselves and what they're experiencing could possibly blow me away if I ever. So you can see this point of view leads to all sorts of radical implications. It took me decades to even understand what it could mean because we're so used to thinking inside the headset.
I know it is very, very mind bending. It's almost like sort of taking the blue pill at some point, and like legitimately really sort of leaving reality altogether. Because there's two people who firmly love science, so ingrained within it, and if someone just has to pop in right now and just shadow and watch us, I mean, they'll think we're completely out of it.
Right.
This conversation is completely out there. Right. And all you can think is that you just haven't taken the blue pill yet.
That's right. But what's led me down this blue pill path is the mathematics and the science. I've been led kicking and screaming the whole way. I mean, so I understand when anybody has an objection, I completely understand. I had that objection, and the only reason I'm saying what I'm saying is that I had to go with the science. It's just plain the fact that our best science tells us that space-time isn't fundamental. And when you wrap your head around that, space-time and objects in space-time are not fundamental. That's what our best science, that is the start of the rabbit hole. And that's not an LSD-induced rabbit hole. That is a scientific-based rabbit hole. And I've been chasing the mathematics and going wherever. And that's what you have to do as a scientist. You have to be intrepid and be willing to let go of flat Earth, be willing to let go of Newton, be willing to let go of Einstein, be willing to let go of quantum mechanics, and be willing to let go of space-time. You've got to be willing to let go of all of it and go into it.
Yeah. At what point you mentioned that the one? I mean, you spoke about this earlier, and I think we should at some point round back to that and just touch on it more because it seems like quite some fun work that's happening at this very moment. But you mentioned that at that point you and Bernardo just diverge a little. At which point exactly does that happen? Why is it that your version of the one within this trace chain is something that would make you two guys clash in your views?
Well, I'm not sure that we would clash too much, but I'll say where we might have some differences. And again, Bernardo's a brilliant and a good friend, and if there's something where we differ philosophically, I defer to him because he's a real philosopher and I'm not. So, right. But Bernardo has recently been saying that there is a way of interpreting integrated information theory. that would be compatible with analytic idealism, his view. And I'll look forward to having a conversation with Bernardo about this, because he's brilliant, so I'll probably stand corrected with what I'm about to say. But it seems to me that integrated information theory does assume that there's a substrate, and they're very explicit. I mean, one of their IIT 4.0 paper. I mean, I looked, and substrate is mentioned dozens and dozens of times. So not just, it's not a minor thing. Substrate is front and center. Now, if I gave you a theory of space-time, and I said, but there's a substrate to space-time, then I would assume from that you're saying that space-time isn't fundamental because there's a substrate to it, right? So if space-time is fundamental, then I'll just talk about space-time. I don't need to talk about anything deeper than that. No substrate to it. So if I'm talking about a theory of consciousness, and I want to say consciousness is fundamental, well, then I don't need to really be talking about any substrates. I mean, consciousness is the final substrate in that theory. So this is what I would like to talk with Bernardo about, and I'm sure he'll have something that will make me think deep. But so with all, he's a good friend and he's brilliant, so I'll be interested to do it. But my attitude right now is a theory of consciousness that's scientific and in the spirit of analytic idealism doesn't need any substrate for the consciousness. You just posit the nature of that consciousness, and no, you don't posit any substrate. And you don't need to posit some combinatorial properties of that substrate, like integrated information, causal properties of that substrate that quantify how much consciousness there is. Consciousness is conscious. You don't quantify it. It's there. You can quantify how much access you might have to the consciousness through a particular headset, but consciousness itself is just consciousness. It is fundamental. And so in IIT, there's always this thing we talked about earlier, that these circuits, there is no consciousness in them, in these brain circuits, and these circuits, maybe they do have consciousness. That whole thing of assigning consciousness to substrates, neural substrates in this case, is wrong-headed. It's just completely wrong. So that's where, again, I'm sure I'm going to learn a lot when I talk with Bernardo about this. I really just learned about his views in the last month or so on this. So that's why I haven't had a chance to really talk with him.
It also caught me by storm, because I'm scheduled to chat to him, I think, in a month's time, and we spoke, I think, about a few months ago. And when we spoke, I had no idea that he would that view. I also had no clue that he would go down that view either. It was quite strange to me as well, and I'm curious, and I'm keen to ask him as well.
Yeah, I'm going to ask. I'll ask him as well, and I'm sure he'll have something really good to say. And I'll try to push back on this. You don't need a substrate, and see what he says.
I'll try the same, and I'll also let him know. If I speak to him first, I'll let him know without causing any sort of debate. But Bernardo loves to debate. By the way, he prefers when someone actively debates in a respectful manner, though.
In a respectful manner, right? Yeah, exactly.
As long as it's respectful, he loves the debate. He enjoys it. He actually told me the last time, please actually be more stern and strict with the questions.
Well, I like sharp discussion in the sense that it's intellectually on point and deep. Yeah. Having it be personal, I'm not interested in having it be personal. That's at all.
Me neither. I told him that I was trying to just be nice and relaxed for the podcast. I just try and make it a nice, calm environment.
But on Bernardo, I'll just say that he's brilliant mathematically, and I've asked him to join us and work on the mathematical side of this, and I want to do that. I would love to get Bernardo, because he's got the mathematical chops, to actually work with us on this theory of conscious agents and show analytical idealism through the math of conscious agents. But we'll see.
I mean, to get a PhD in engineering and philosophy, you must know your stuff. There must be something going on there that you're able to kind of bring these two fields together and give people quite a unique perspective, at least.
Absolutely.
On reality.
He is unique.
Yeah, I think he's very busy with the Essentia Foundation, so I see them doing quite a lot of work lately. So, probably just like you, probably a lot of it on your plates. Don, in this virtual reality, is there anything you want to call it? By the way, do you prefer calling it the virtual reality? What do you prefer calling it?
I think headset is the easiest for most people.
Okay.
So Spacetime is just a headset, and I think that I say that because everybody can sort of relate to that.
Okay, within this headset, how does this headset account for? I mean, we know time now based on this is an illusion, but then how do we count for the beginning? Let's say the Big Bang within this headset. How is that conceptualized within this framework?
Well, so the time itself of the Big Bang is an illusion. So what we have is a Markov dynamics in which the entropy is not increasing. Then we say, so we have this big Markov chain. There is no time, but now let's look at it from a perspective. Let's do a trace chain. So we start off talking about, so let's take a big chain. Let's do a trace chain. Well, we've lost information. Well, so now we're going to, we're going to induce an arrow of time. And it's going to look, depending on which trace chain you use, it might look like the Big Bang and then, lifeless evolution of galaxies and stars and so forth, and then life and then consciousness. And it might look like that. But that's, the entire story is an artifact of the projection, and it's not a deep insight.
It's fascinating because me trying to ask you what happened before the Big Bang is kind of like me asking you what happened before the one, or what is that something you're even thinking about at any point?
Well, absolutely. And by the way, I should say that what I was the answer I just gave about the projection and Big Bang just being an artifact, I actually want to actually do that. I want to actually write down a big Markovian kernel in which the entropy is not increasing. Choose a projection and then show, wow, when I look at it through this projection, look at that, I do get this weird thing seem to be evolving and growing. In other words, this is not a hand wave. I am proposing computational model. There is a Markov dynamics beyond spacetime in which the entropy is not increasing. Take any projection of it where by conditional probability, like trace chains or something like that, the entropy will be increasing. Study those. Study all the different ways that can happen. Our universe with the Big Bang will just be one of the possible kinds of ways that the universe. So in other words, we can study cosmology from this point of view, and we can understand. Right now, if you take space-time as fundamental, then the notion of the Big Bang and the singularity is an unsolvable problem. What do you do with it? But if you realize, oh no, that's just a headset projection of a deeper thing in which there is no singularity. I've erased the singularity. That's what this mathematics is. I've erased the singularity and showed you get the singularity because of a projection, not because of the truth of the deeper reality. So this is not, so I don't want people to think, it might have sounded like it was just a hand wave. No, I'm offering a technical computational program.
The same, yeah, exactly. I mean, that's the biggest difference between a lot of other idealist theorists, is that you're using computational, you're using mathematics and physics in a very precise manner to try and show people what you're talking about. I mean, conscious agents and the subatomic world, you came with that very strategically, knowing that this is the core layer of reality according to us and the way we perceive it. And that's why you guys wanted to touch that base reality. And you said you don't want to go straight for the neuron, because that is it's a lot harder. There's probably a lot more that's going to have to go into that. Do you have a sort of a hierarchy of what you think you want to go after? So from the subatomic world, we just mentioned going into cosmology at some point. Anything in particular that you're kind of taking these maths into at some point, or spearheading into in the future?
Well, yes. Right now, what I'm working on is a specific technical problem, which is we've mapped a Markov dynamics into decorated permutations. Physicists have mapped decorated permutations of positive Grassmannians, into scattering amplitudes. So I want to tie that whole thing together. So what I'm working on right now is interfacing our decorated permutations with the decorated permutations and the Grassmannians of the physicists. I've got to get that map absolutely precise. So, and I've been working on that, and I gave 2 proposals to my colleagues in the last 3 weeks, and they're both wrong, but they're both a piece of the puzzle. But I put them out. I thought no, it's wrong. So I'm realizing I have to dig deeper. I'm gonna have to really study these positive Grassmannians more deeply and write down a more serious. So that's what I'm working on right now. Is because I then want to be able to. But once we have that, then we can do our computational experiment about quarks and gluons. We have to show how we can go all the way from the dynamics of conscious agents through the decorated permutations to scattering amplitudes and properties of particles. So that's why I'm focused on this technical issue right now. Markov decorated permutations mapping to Grassmannian decorated permutations. Clean technical problem. And I'm working on it. And I'm not a mathematician, so I'm having to learn about positive Grassmannians, and I'm just learning as I go. But I'm motivated. So that's what I'm going after now. But then my guess is I'm a cognitive neuroscientist, and I would love to be going after the brain, but the brain is, I don't know, 10 to the 50th or 10 to the 60th quarks and gluons, whatever it is. Maybe I should start with 2 or 3 quarks and gluons, and work there, and then work up to, protons and protons and electrons. So do the nucleus and the atom, and then maybe some simple molecules. Then maybe by the time we get to molecules, maybe we'll know enough to actually know, for example, about neurotransmitters. What does a neurotransmitter mean in terms of the dynamics of conscious agents? But ultimately, we'll have to get then to axons and neurons and synapses and understand. You can see we have to reverse. So the problem is we have to reverse engineer a headset. We thought, so neuroscience is far harder than we thought. We thought that we look inside through microscopes and we see billions of neurons and trillions of synapses. And that's really complicated, and we think that that's the truth. No. That's a thin veneer on the complexity. The true complexity is far, far greater. Let me give you just a taste of the complexity. If I have a conscious agent that has just 10 color experiences, I'll say 50 color experiences, 50 color experiences. You can perceive 6 million or 7 million different colors. You can discriminate 6 or 7 million. So this is trivial. 50 colors is nothing compared to what you can do. In our theory of conscious agents, the set of possible Markov chains for consciousness is dealing with just 50 colors is the Markov polytope on 50 states. Okay, so it's called a Markov polytope in 50 states. And this is a polytope. It's a geometric object that we have to study to understand all the dynamics of consciousness. And it has little vertices on it, like a diamond. It's got little points on it, right? It's got facets and edges and points. You know how many points with only 50 colors, you know how many points this geometric object has? It has 10,000 times more points than the number of particles in the known visible universe.
Wow, that's incredible.
That's only per 50. So I'm going to need a bigger computer to simulate this stuff. But so consciousness. So we thought that the brain was complicated. It's trivial compared to when we let go of the head. See, the headset was there to really dumb things down, and it succeeded. It really dumbed things down. We thought we were seeing truth in all of its glory. We got the really dumbed down cheap version. As soon as we start taking little steps outside of our little space-time headset, holy smoke, the thing just blows wide open. Consciousness is unbelievably complicated, and I'm going to need a new desktop computer.
And I think the worst part about it is that even as you go on, because the irony is that you'll probably need quantum computers to to try and help you prove that you can go beyond quantum, which is quite funny. But I think something that makes it even worse is that you have people like Mike Levin who are even showing you that you don't have to even go to a neuron to show people what intelligence or a possible mind even is in that sense. I mean, he's blurring the lines completely with his work.
His bioelectric fields are truly stunning.
It's amazing. His work is so
brilliant. No, I've enjoyed talking with him. I have a couple of podcasts with Mike.
And now you're lifting this position where these bioelectric networks also have to sort of at some point be explained now.
Absolutely.
And he's leaving you with a much harder task, I would say.
That one sounds like a very fun task, to understand the bioelectric fields and how they would arise as an interface projection of dynamics of conscious agent networks, right? So absolutely, this is going to be fun to reverse engineer our headset, our space-time headset, and bioelectric fields will be part of it. Neurons will be part of it. DNA, all of that. So in some sense, science is just now taking off the headset. In some sense, we're just now beginning the real task of science. Right now, we just polished the tools on our little headset. We thought we were seeing the truth. No, we were just sharpening our tools. Now it's time to take the headset off and really get to work on what's beyond. It's pretty exciting.
Yeah, it's almost like a post-realism. It's a there's going to be some term for it. Post-realism. There's going to be something where people are now moving beyond this headset if they're going to try and figure out reality in this way. Something. Sorry, don't continue.
Or maybe it'll be pro-realism in the sense that we thought the headset is not the real thing. That's just a headset. Now we're getting into the realism. But our discussion on the limits of scientific theories means that even though I'm saying we're going outside the headset and science is really just beginning, still scientific theories will never be a theory of everything. Humility is going to be required at every step, because we're stepping outside the headset, but effectively we've just moved to a bigger projection of the one. All we can ever deal with are bigger and bigger projections of the one. And no matter how big our projections are, they will be literally measure zero of the one. So humility is required.
I'm glad you brought it back to that, because I wanted to ask you. I mean, you started off by talking about the stress chain, figuring out the one, and this new information. If you can just try and sort of conceptualize this, what you think this is, the one. What type of? Is there any way for you to wrap your head around this? Do you think you can?
In a way, I think we all can in the following sense. If it's true that you are the one experiencing itself through a headset, and the reason that you don't feel that is because you're in with both feet on the headset. You really believe that you are the avatar in the headset. And that's part of the whole game. I mean, the part of the whole game is for the one to completely lose itself in the headset and to slowly wake up. If I don't really believe it for a while, it's not going to be real for me to say I'm not that, because I never really took it seriously. So I need to take it seriously and then let go. So I think it is possible, even while we're still having these avatars in the headset, through meditation, to let go. But to the mind, so this is now where it starts to sort of go with what spiritual traditions some have said, and that is that the truth can't be understood by the mind. So no words are adequate, no scientific theory is adequate, but you have another access to that realm. That's not a conceptual access. It's direct. You are that infinite intelligence. That's what you are. And any concept that you have of yourself is only a projection, necessarily. So the only way to answer your question is to, of course, I do my science, but to answer your question, to really go deep, I have to let go of all of my concepts, including all of my scientific theories, completely. No thoughts at all. So literally a space of no thoughts, no conceptions, and just aware of awareness of awareness. And then I think that's where you then begin to know yourself, not as you know an external object, but you know yourself directly. And my guess is that that goes infinitely deep. In other words, if you do that for 5 minutes, you experience that for 5 minutes, you've not scratched the surface yet. Try it for 500 years, you've not scratched the surface yet. That's how deep you go. So somehow the deep answer to your question is, on the one hand, we know the one by looking at this projection and doing all of our science, and we know the one by doing that really, really carefully and then saying, I transcend that. I'm not that. That is a lower limit on my capabilities, and that's not the limit of who I am. Then we can go beyond that by letting go of all thoughts and just being the awareness of awareness. And that goes infinitely deep. And so you can know it directly, but the mind will say, because there's no concepts for the mind to deal with. So the intellectual mind will say there's nothing there. But frankly, my own experience is that if I want new ideas to do my science, I need to go into the space where I let go of all concepts. I need to actually tap into that infinite intelligence and just be in absolute interior silence. That's where all the good ideas come from. Then you bring them back in. So the mind really isn't, I mean, it has its own little limited intelligence, and you can do mathematical computations and so forth. But if you want deep insights, you got to let go of the mind.
Yeah. So we are one infinite intelligence.
Yeah. Yeah.
Yes. Well, sorry, Don, I'm not sure if I haven't really picked up on you saying this much, but when did you start calling it the one?
I was influenced by Federico Faggin.
Yes.
So Federico's a good friend, and I've really, he's a wonderful man, and he helped support this research and he talked about the one. He didn't give a mathematical model of the one, and of course you can't, but he talked about the one, and I, at first I didn't use the term, but then I realized that my mathematics was pointing me toward the idea that there was going to be not just a network of separate consciousnesses, but I was going to have to recognize that, yeah, they can combine, and ultimately there's some notion of one. And so I decided that was sort of the least tendentious word that I could use. But I don't think right now that I have a mathematical model of the one. I have a mathematical model of projection of the one in terms of conscious agent networks. So that's why I started using the term the one, and maybe the last few years I sort of filtered in when I started thinking more and more about the deeper structure of this network of conscious agents.
So do you think the ultimate purpose at this point then is the one sort of experiencing, well, having multiple experiences via us, the avatars, in this infinite sort of some essence beyond space-time?
That's right. Enjoying those experiences and then learning what it is by learning that no matter how exotic and impressive those experiences are, they're trivial compared to what the one is.
Yeah. And then do you think, Don, with that in mind, if you had to take certain other theories that are physicalist, like they go a bit beyond that when they think about a multiverse, would a multiverse in this context to be the others? And maybe there's one in this universe, and then there are others in sort of other universes. Do you think?
Well, one could interpret. So there's, of course, a technical meaning of multiverse.
Yes.
That some physicists have, and also many worlds. There's a different kind of technical thing there, but one, just at a top level, one could say the idea that I have of multiple headsets could be sort of like multiple universes, multiverse kind of thing, possibly. But when you get real technical about it, I mean, like Max Tegmark has, his level 4 multiverse, which he it's different now from what I just said, right? I was saying we could think informally about all these multiverses being just different headsets, and there's an infinite variety of them. So that's top level connection to your idea, but getting down more to brass tacks, like what real physicists are using multiverse for, like one concrete example is Max Tegmark at MIT. His level 4 multiverse, he's saying that mathematics is fundamental reality. Okay, so the fundamental nature of reality is entirely mathematical, and there's an infinite variety of possible mathematics, and so there's an infinite variety of mathematical universes. And so I agree that mathematics is endless. It's infinite, but I don't think that mathematics, of course, I think Tegmark is brilliant, and in this realm, I would probably be set straight by him. But anyway, here's my idea as it is, that when it comes to the nature of reality, consciousness, what is the relation between mathematics and consciousness? My feeling is that mathematics isn't the whole thing. That the consciousness, put it this way, the living organism of consciousness has mathematics as like the bones, but the bones are just the bones. They're not the whole living organism. And they're essential. Mathematics, I think, is essential, but it's not the whole of the living organism of consciousness. So that's sort of my feeling about how my views fit with like multiverse kinds of views.
It's fascinating to me how it's becoming so poetic over time. Because I mean, the more you're obviously talking about this so much more lately, and you're trying to get people to understand it, and it's starting to slowly develop its own sort of moral, practical significance as you have to build on it and apply it. Did you ever foresee yourself becoming someone who will sound so spiritual, almost guru-like in your life?
No, I mean, it's sort of, I've been pushed kicking and screaming.
I can tell.
This kind of thing by the mathematics, but on the other hand, at some point it's time to quit kicking and screaming and just say, hey, this is what the next step in. I mean, physics is telling us the space-time is over and quantum theory is not fundamental. So get over it, move on. And so physicalism is dead. Okay, get over it. It's time to get over it. And now, on the other hand, you might say, well, am I jumping in full, with both feet to spiritual traditions and just buying what they say? Absolutely not. I'm having respectful conversations.
Yes.
So I listen respectfully and carefully, and I treat what I hear from spiritual traditions the way I treat what I hear from scientists.
Yes.
I listen respectfully with a big grain of salt in science and in spirituality. There is nonsense in both realms, and there is deep wisdom in both realms. Exactly. And it's up to us to take what looks good, turn it into. So spiritual traditions, I think, have a lot of insights, and there's clearly a lot of nonsense. I mean, they're famous for wars that kill each other for thousands of years. So they have deep insights, and there's deep dysfunction. And the issue is to understand which is which, and maybe, for example, it may be that many of the spiritual traditions themselves are very deeply onto something, but the practitioners don't understand it, and they're the ones that are doing the killing, right? It's not the philosophy, or it's not the insights that the gurus have had. It's the misuse of them by the followers that's the problem. So we have to be very, very careful. And don't dismiss the philosophy based because some followers start doing some nasty things. Yeah. So there's pitfalls everywhere. So as a scientist, what I want to do is to listen respectfully to the ideas, then look for mathematically precise statements of the ideas, ones that look interesting, right? And then turn them into testable theories. Ultimately, spiritual traditions tell us that their words are just pointers. Right, like the Tao Te Ching, the very first sentence in the Tao Te Ching says, "The Tao that can be spoken is not the true Tao." Once you understand that, then you can go ahead and read the rest of it, because now you understand that everything that's said is not the truth. It's not to be taken dogmatically. It's to be taken as a pointer for you to explore for yourself. So it's not about, so you better say it exactly this way or you go to hell. No. These are all pointers. Take them in the spirit of pointers. You have to explore for yourself. So the spiritual traditions have said that, but wouldn't it be nice to have pointers that tell you their own limits, right? And that's what science gives you.
Yes.
You have space-time. It's mathematically precise. And you know what? It falls apart at 10 to the minus 33 centimeters. We can tell you where that pointer falls apart. This is the antidote to dogmatism. So what I would love to see is that the precision that we've got in science is brought over to spirituality, so that we now can have pointers in the spiritual traditions that are evolving. It's nothing to boast about that I'm using the same pointers that they used 3,000 years ago. I wouldn't brag about that. I would say that's a problem. I mean, we would like to have this thing evolving and get better pointers, and pointers that in themselves tell you the limit, the scope of the pointer, how it's going to be useful to you, and the limit of the pointer, so that we don't then fight over the pointers and kill each other over the pointers. And you don't believe my pointer? Well, you go to hell, or that kind of thing.
I mean, this has been such a fascinating conversation, because I mean, it's different from the first two. In the first one, we went into a lot of detail on all the theories. Second one, we went into a paper directly. As I said, I tried to make this one as practical, or almost a moral philosophy aspect of all of this. Yes. And I mean, you're brave enough at this point, clearly, from all the work you've done, to even mention the L word. I mean, the love word in science. People, you know how some scientists get when you say the love word. Yeah. Just talk to me about this bigger picture meaning, and how people can take all this information, because now we've got 2 podcast episodes they can look at. They've got all the others you mentioned as well. You speaking to Tom, you speaking to Bernardo, everything else. How can they bring all of this information together and fulfill this purpose of the one, or make it a more, let's say, a better process for all of us together?
Right. Well, I think that one way to think about what's happening with humanity is, part of humanity for thousands of years has said, this is just a headset. The spiritual part. They said, the space and time is not fundamental, consciousness is fundamental. But they've said that with only the tools of natural language. But they've not had mathematics. Then there's another group of people who have been saying, no, the headset's everything there is. The physicalists, right? This is it. But they developed these mathematical tools and careful experiments, and they gave us the technology. So we have one group, but then the group that's developed all this technology and all the mathematical stuff, and all of a sudden their own theories came back just in the last couple decades and slapped them in the face and said, wake up, space-time is just a headset. And it's a cheap headset. It falls apart at 10 to the minus 33 centimeters. So now scientists, very few right now, but some, and I think more, as we really understand the slap in the face that space-time is doomed, a lot of scientists are going to be waking up going, wow, we have to go outside of space-time. Well, it's this big group of people that are already out there. They're saying, well, welcome, latecomers. We've been here for a long time. They've done a lot of exploring there. But they don't have the tools that science has. So there are 2 groups that have half of the puzzle. This one group has a big part of the puzzle. They've been doing meditation, and they have informal descriptions. This group is just coming late to the party, but they have incredible tools and precision and experiments. Let's get the 2 together, and spirituality and science are just 2 aspects of human exploration. It's all human exploration and understanding who we are. They're not separate. We've assumed that they're separate. There's been this division, especially since Galileo, his house imprisonment by the Catholic Church, right? There has been this huge division. It's time for us to grow up and bring the 2 halves together. It's going to be painful. Any marriage like this is going to be painful, because there's dogmas I think the spiritual gurus don't have dogmas, but the followers do. Many followers of spiritual traditions get tied up in the pointer saying that pointer is the truth. This pointer is the truth. No, it's just the pointer to the moon is not the moon. The Buddhists will say it's just a pointer. It's not the moon. But the many followers just don't get it, and that's just human nature. So it'll be painful on both sides because scientists are going to have to let go of physicalism. And for most scientists, to let go of physicalism is to not be a scientist. Yeah. But science is not a particular theory, namely spacetime. It's not a theory. Science is a method of careful experiments and careful theory building and testing, and a cycle of experiment and theory. That's what science is. Physicalism is one theory that was helpful for several centuries and has outlived its usefulness. It's time to let go of that. And you don't let go of science by letting go of physicalism. In fact, if you don't let go of physicalism, then you do let go of science because you refuse to go where the science is telling you to go. You've got to go beyond space-time. So it's painful because something that both sides have deeply believed will turn out to be deeply false, and other things will turn out to be true, and we'll have to pick what are the true things, or I wouldn't say true, the next useful steps. Ultimately the truth is just you without any concepts. That's just the only truth I can talk to is you without any concepts about it. But in our efforts as human beings to put together pointers on the spiritual side and on the science side, the two can work together. And so that's to integrate what we've been talking about. I would say that that's the top level picture. Let's have respectful, but not credulous. Not stupid, but a respectful conversation, and to find what are the good insights from both sides and what are the stupid things from both sides, and bring the good insights together and have a scientific spirituality that's rigorous and human.
Yeah, no, I completely agree. I know I've always thought that as well. I mean, East meets West almost, yin and yang. You have to sort of bring these concepts together because there's so much different types of knowledge and bodies of knowledge that even the general Western science it did not understand a lot of Eastern science or Asian philosophy, exactly. African philosophy. There's a lot to it that a lot of them just have never had access to and don't get. But they all have profound things to say.
I agree with you. I agree. And I think that in the dialogue, the informal natural language descriptions of these traditions can be translated into mathematics. And at that point, then we can start to get the real power of the ideas. Right. I like to use the example of Einstein when he developed the theory of general relativity. The big idea came like in 1907 when he realized if I was in an elevator standing on a weighing scale and the cord of the elevator was cut and this went into free fall, all of a sudden I would weigh nothing on the scale. I would weigh nothing. That was his big insight that led to general relativity. But it took him years, and he was Einstein, so he was brilliant. It took him years to turn that into mathematics. But when he turned it into mathematics, a year later, or a few months later, Schwarzschild, some German soldier actually, but brilliant, solved his equations and proved that there were black holes. Well, Einstein had no idea that his equations would lead to black. He didn't like it. He didn't believe in black holes.
Yes.
So what happens is your theories become smarter than the person who wrote them down. You become a student of your own theory. Even if you're an Einstein, you're not smart enough to know everything that your theory is going to teach you. And you see, so that's what's going to happen with spirituality. Does not have that yet. They don't have the benefit of taking the ideas, making them so precise that you can become students of those ideas, where even the teacher who wrote them down doesn't know all the implications and has to become humble before their own mathematics and let it teach them.
Yeah.
That's when spirituality gets to that point, sign me up. I'm really interested.
Well, sign me up too, Don. I'm also keen to go on that journey as well. Listen, Don, it's been another pleasure for me. It's been such an amazing journey. Chatting to you is always so much fun, and I still can't wait for us to have many more along the way. Anything on your mind? Anything else you want to say?
One thing I'd like to say, and that is one question that people always bring up is you use theory of evolution to show that we don't see the truth. Right? We don't see reality as it is, but then that means that evolution isn't true, and so you shot yourself in the foot. And so I should address that just briefly. The idea is this. This is the way science progresses. This is nothing special about me. This is the way you put down a scientific theory and you make it mathematically precise. And when you do that, then the mathematics tells you what the theory can do, but it also tells you where the theory ends. Einstein's theory ends at 10 to the minus 33 centimeters. Well, that's all I'm not doing anything weird or special. This is just the way science works. You take the mathematics of the theory and you ask the mathematics, what's the limit of this theory? And the mathematics comes back and says, here's the limit, 10 to the minus 33 centimeters. Well, in the case of evolution, it also says the same thing. The limit is the very assumption of space-time and objects in space, organisms in space-time competing for resources in space-time. That ain't true. And in Einstein's case, the mathematics comes back and says, space-time, that ain't it. It's not fundamental. In fact, it falls apart at 10 to the minus 33. You're going to need to find a structure outside of space-time. Evolution is saying the same thing. So we're not shooting ourselves in the foot. You have to understand this is the way science progresses. The mathematics doesn't prove that the assumptions are right. The mathematics tells you the limits of the assumptions. That's so. So I just want to really, it's not a minor point. So it's how science progresses.
It's almost like going back to the old way of thinking, like falsification in a sense. It's kind of, you're looking for that sort of that cap, that end point. Where does it end? Yeah.
So, where does, well, and in fact, if you think about it, that's what scientists should be looking for all the time is like, we know that this is not the theory of everything, right? We know it. If I can write it down, it's not the theory of everything. So do I want to be an idiot and just, or do I want to be the explorer? So let me be the explorer. Where's the limit? So let's find as soon as possible what the limits of this theory are, and then go to the next one and then explore its limits. That's fun. It's boring to just get stuck in the same paradigm the whole time.
Yeah.
And I would just say one short thing too, and this question always comes up.
Oh, take your time, Don. I've got time. Don't worry.
Okay. Well, I won't perseverate though. Just one last thing. A lot of people will say, look, you're saying that the moon is just an object in my headset, and it doesn't exist when no one looks. You create it when you look. Now, give me a break. Everybody goes, give me a break. So suppose I take, I don't know, an apple, and I stick it in the ground and leave it there for 5 weeks. And then you come and dig it up. You're going to find a rotten apple. Well, doesn't that prove that the apple was there the whole time and it existed even when you weren't looking, right? And rot was going on when you weren't looking. And so this whole nonsense. Well, and all I can say is, if you in questions like that one, and there's many, I get dozens of questions all the time.
I can imagine.
Right. In all those questions, the way to answer it for yourself is to just put it into virtual reality. So imagine you're playing a virtual reality game, a multiplayer virtual reality game, and try to put your question into that realm. And then you'll see how it works. So for example, I'm playing multiplayer tennis, and I hit the tennis ball to my partner over on the other side, and I say, the tennis ball only exists when I look. It's just pixels in my headset. And the other guy says, Oh, no, no, no. The tennis ball is real. So, and he takes, both guys are in virtual reality. He takes the tennis ball and he drops it and he looks away. He says, I can't see it, but Don, can you see the tennis ball? And I say, yeah, I can see it. So that proves it really exists. No, it doesn't prove that. I turn my head and I'm rendering it because I'm looking at it. So it doesn't exist. Well, then he says, well, but when I hit the tennis ball to you, you hit the same tennis ball back to me. So it proves that there's just one. No, I have a tennis ball that I'm experiencing in my headset. You have a tennis ball that you're experiencing in your headset. Those are so all the questions that people have before you write me an email about it. First, try it out yourself. See if you can solve the problem yourself by putting it into virtual reality, a multiplayer game, and see if you. Here's the key idea. There is something that exists independent of what you see in your headset. There is something in that analogy. It's some supercomputer that's coordinating the game, but there's no tennis ball in that supercomputer. There's nothing green or fuzzy or round in that. So there is something that exists independent of you, but it's utterly unlike anything that you see or experience. Utterly unlike that. That's the only thing you have to wrap. Once you wrap your head around that idea and use the VR and the supercomputer analogy, you'll be able to solve your own puzzles, and then you'll see how fun this approach is. But until then, I see people, they can't really start to explore it because they just see these obvious contradictions that they think are make the whole thing a non-starter. So just put it into virtual reality, and then you can start to really explore the space.
And another way to sort of see that, another way I had a question on, and I forgot to ask you about that, was also when, as two perceivers are sort of seeing something, the fact that they're able to render the sort of same thing in within your theory is actually because, in essence, this is still coming from one sort of the one. So it's not like they wouldn't have access to the same information at some point. It's kind of like you do have this shared access to information within reality.
That's absolutely right. It's like the supercomputer in the VR analogy. Is the shared access. And the one little proviso I would give is that we actually don't know that others are perceiving the world like us. Right? There's something called synesthesia.
Yes.
Where you know about, you probably know better than I do, where people have experiences that, like Carol Steen, everything that she hears, every bit of music that she hears, she sees a geometric object with a specific shape and a specific texture to the surfaces and colors and so forth. And I've actually met her and talked with her in person about this. So, I mean, she's living in a world that I wouldn't have imagined was possible. She hears music, and every time she hears the same piece of music, she sees the same object doing a complicated movement with a beautiful surface on it and so forth. Well, and there was a guy named Michael something or other who everything he tasted with his mouth, he felt with his hands. So mint felt like a tall, cold, cool column of glass.
Yeah, you get some patients who when they read, they can smell it or hear sound. Yes. It's incredible, some of the synesthesia patients.
That's right. So you're right that because we share the one, we can have some expectation of understanding what the other world, what the other person's world is like. But I just want to put out this proviso that don't think that you know everything. It may be that their world is very, very different than you would ever. We have good experimental reasons to believe that our visual and sensory worlds vary from person to person, and sometimes dramatically.
I was going to say, because in that case, someone who's schizophrenic or has fully blown psychosis has almost left that headset in a different way. Or
yes.
How would you sort of explore that within this? Like a fully blown psychosis where the person is completely out of touch. There is no link at all to what you and I are experiencing within our headsets. How is that sort of explored within this analogy?
Of course. Now I'm a complete amateur. I'm not a psychiatrist or anything like that. So just so
everyone knows, this is a philosophy / podcast that's not really a mental health podcast directly.
Exactly right. So with just to be clear. So then I'll speculate given that. So I'm not a professional psychiatrist, but it seems to me that going back to the idea of the one, and the one plunging in with both feet and losing itself. But giving itself, we didn't talk about this, but I think the one gives itself little nudges to wake up. And that's the suffering that happens when I get identified with myself and I'm trying to be important, and my ego is trying to clash with other people. I'm trying to show that I'm smarter than you or better than you or faster than you or have more money or better cars. All that competition that we do is painful. It causes suffering. It's the very act of me being in any way hostile to anybody else. It causes me suffering, and to be competitive in any way like that is causes me suffering, and that suffering is the wake up call to the truth, which is that person that I'm competing against, or that I'm angry with, is me. That is me under a different avatar. I've got the suffering as a gentle way of, and sometimes not so gentle, as later on, of getting me to wake up and to, but that's part of the whole thing of waking up to who I am. And so the psychoses, I think, are cases where the suffering has gotten, in many cases, sometimes you can say this person had a tumor and that's why. I mean, we look in there and there's a tumor, right? So that the tumor is sort of the headset version of saying that there's something wrong in the network of conscious agents. Something went haywire in that headset construction. But in this other approach I'm thinking about, is that the extreme psychological pain that you get with extreme psychiatric patients is really the one using suffering of an extreme kind to wake itself up, to wake that particular itself in that avatar to wake up and to recognize that there's nothing to worry about. Right? If you're in the virtual reality game and you believe you're the avatar, if someone's shooting up the avatar, it's scary as hell. But if you go into the game, my avatar is just an avatar, they can shoot it up all. It's a completely different game. There's no reason to be upset. So that is that kind of, it's waking up to, oh, this is just a VR game. And the psychosis patient, the one I'm talking about, is the one who needs to wake up, but is still so identified with the avatar that they're in a world of pain, in a world of fear, in a world of. So that's, again, amateur hour from Hoffman. I'm not a psychiatrist.
Yeah,
but just kind of.
Don't worry. I always put at the bottom of my videos a disclaimer to let people know that this is more of an educational podcast rather than something you apply to your life. This is not us trying to be gurus, everyone. So just do not.
Exactly right.
Yeah. And as a doctor myself, I'm not. This is not me coming out trying to give people advice either. This is my intellectual pursuit of trying to understand these questions that I love so much. So right. Just so everyone knows, that's just our disclaimer for the moment. Don,
it's not professional advice.
Yes, this is not professional advice at all. Don, do you ever get worried or concerned about the fact, maybe even, I don't know, do you even like it, but maybe that you, maybe Bernardo, all you guys within this idealist, it's almost like a new wave of idealism that's taking place right now. It's quite fascinating to see as well from my perspective, doing this podcast and taking part in these conversations. Do you ever get concerned that you guys are slowly growing a cult, or maybe that people are going to take some of this and take it way beyond you guys, like to a point where they form their own sort of dogma type groups? Does that ever concern you in any way?
Well,
it's a very random question, I know, but
yes, it does, in the sense that my efforts are to make it a mathematical science, which still doesn't preclude a cultish kind of approach, but it really helps to avoid it. When you don't just have words that you're pushing around, but you have a mathematical theory that can slap you in the face when you misinterpret it, right? And when it actually says no to you. Like when Einstein thinks that there are no black holes, and the theory comes back and slaps him and says, no, there are black holes, live with it. So that's what I want is a mathematically precise idealism, what I call it conscious realism, because of some philosophical baggage that idealism brings. But so I call it conscious realism, but it's a version of idealism. I want a mathematically precise. My goal is to get this thing launched with enough mathematical rigor and enough momentum that it will take off and be a real science, a real mathematical idealist science. I see idealism in the past has had something of an anti-science flair to it. I mean, Berkeley, in some sense, brought up his idealism as a reply to the physicalism that he perceived of Newton's science.
Yes.
And
Berkeley had God as part of that, as his main sort of core to the whole thesis.
That's right, and it was sort of it came out of an opposition to the Newtonian science, and many idealist theories. In fact, I'm not really sure if I know of any like idealists who have said, now let's go and make this a mathematical scientific theory. I mean, this is not.
Yeah.
There are some quantum physicists who early on who interpreted quantum mechanics in idealist ways. Von Neumann and others gave idealist interpretations, but that's not what I'm talking about. Someone saying, let's take idealist ideas and make a mathematically precise scientific theory out of idealism. And Kant, of course, did a lot of deep philosophical ideas about idealism, but that's different from making mathematically precise theories. And so there's been this anti-science flavor to a lot of idealist thinking. And it's I think not necessary, and in fact it's not helpful. I think that idealism is the next step, and we need to make it mathematically precise and show that physicalism emerges as a headset, as a projection of a much deeper theory. So that, by the way, we don't throw away our physicalist theories. We show them as special cases of deeper theories. And we use our physicalist theories as tests for, we're making new theories beyond space-time. How do we test them? We test them in space-time. We test them like with scattering experiments, where we know the physics of the scattering. So we don't throw away our old theories. We are grateful for quantum field theory and general relativity. We're grateful for evolution by natural selection. These are wonderful theories. They are going to tell us when we make mistakes with our theories outside of space-time. They will come back and slap us in the face because we have to project them back into their domain. And they say, well, now you're in our domain. And I say no, or I say maybe. Maybe you can continue in that direction. You're not wrong yet. So that's so ultimately, I think idealism needs to be, and I'm trying to work toward that end to make it a mathematically precise science. And then I won't have to worry about the cult thing that we talked about earlier and so forth.
The reason why I asked, Dan, is because you see it when you look at the comments and the way people talk about your work, Bernardo, etc. I mean, the way some people are really, really in love with it. It is their anti-anxiety cure. They listen to you guys to kind of get to get themselves out of tough situations. They use this as a spiritual escape. And I've seen comments, and I like them. I always tell them, like, it's great. It's great that you guys have such an impact. But at that point, you do come with a lot of power. I recently read a paper by someone. I can't remember who it was by, but it was about Bernardo Kastrup's idealism, and I can't remember who wrote it, but it spoke about this. It was against it, of course, but trying to dissect the fact that it's almost cult-like, and it's kind of like a group of thinkers coming together, forming this new wave. It's almost like the New Age atheism movement that happened with Dawkins, Dennett back in the day, but except in a shift towards a positive movement. So like love, universal mind is one, very, very cult-like. And I'm not accusing you of this, but I'm just saying you can actually see it in the comment sections. You can tell people do really love your work, and there's a big need for it and want for it, clearly.
Well, I would say for those who love it, the best thing that you can do is, if you have the talents, is to study the mathematics of it and contribute to the mathematics and push it forward. Or if you don't yourself have that talent, and few of us do, find a friend who does.
Yes.
Get them.
Like me.
The way to really help this is to move the science forward. And as we move the science forward, if it continues to give us psychological comfort, fantastic. If it prods us in ways that we're not comfortable with, so be it. We have to go wherever truth leads us, or at least the projection of truth that we can see leads us. So that's what I would suggest is I absolutely will say my thoughts on this are baby steps. And everything that I've said are baby steps. It's in just a few years, hopefully, even within my lifetime, everything I'm saying will be seen as trivial compared to what we've discovered. Let's move the science forward beyond my trivial ideas right now. Let's get this thing into a real substantial science.
And I mean, it would be crazy. I mean, the more you guys find out, the more you see. You could almost be seen as the link between us and the one, because you're going to take us closer. You're going to take us closer to us altogether.
No, it's just the one talking to itself.
Yeah, pretty much. You're taking us closer to us.
That's right.
It's beautiful altogether. And Don, thanks so much, man. It's always a pleasure. So much fun. Anything you want to say? Anything else that you think that you really just want to put up?
No, I think I squeezed in all the extras I wanted to at this point. But next time I'll probably have some more things that, I got emails where people ask questions. So next time, absolutely. I would say that I would love to talk with you again. Absolutely.
Yeah, no, I'm eager, and every time I'm going to try to do something different. And obviously, next time, if there's any new papers, if there's anything else you want to chat about specifically, we go back in, do another dissection. It's always fun, Don. It's such a fascinating journey for me personally. Watching from the outside, watching your work, it's always a pleasure, and I appreciate it. Thanks so much.
Thank you, and Tevin, I just love the way that you guide the conversation. It's beyond expert. Well done.